Okay, my name is Andres Marty. I'm an editor here at Key Curriculum Press. Was a long-time math teacher in high school, and thank you for joining us for this webinar this evening on elementary school activities using Sketchpad for number. And we are joined today by a couple of other people from Key. Elizabeth DeCarly is another editor here, and Scott Steckety also works at KCP Technologies. The three of us are available to answer your questions throughout the presentation. Just use the question panel in the GoToWebinar control panel. And our presenter today is Danielle Scher, who is the principal investigator on an NSF grant that is geared towards developing activities for young learners. And without further ado, I'm going to go ahead and transfer my screen to Danielle. And for some reason, I just don't remember how to do that right now. So, all right, change presenter, there we go. All right, so Danielle, I'm going to turn it over to you, and you can take it away from here.
Okay, thank you, Andres. So welcome, everyone. Really excited to have everyone from coast to coast here and from around the world watching this webinar. This is also a very special webinar for me because it's the first chance that I have to show some new activities that are not in any Sketchpad book yet and have not been widely shown. So you are really the first people to be seeing these new activities, and these are activities that I've developed along with my colleague, Scott Steckety, who will be answering your questions tonight, over the last year and a half. And they focus on a dynamic number approach to fractions, decimals, and place value. And as we go through the webinar tonight, I think you'll understand better what we mean by this phrase, dynamic number. So our agenda tonight is to look at a collection of Sketchpad models. We'll have models relating to decimals, and we'll then have a whole bunch of models that focus on fractions. Throughout this webinar, you can type your questions, and Andres, Elizabeth, and Scott will be there to answer them. And from time to time, we'll pause so that questions that come up that I can address, Andres will ask those to me, and I can answer them. Now, one thing to note about everything I'm showing you tonight is that all of the sketches you're going to see are going to be sent to you in a link after the webinar is over tonight. So there's no need to worry about whether you're going to have access to these models or the sketches that I'm showing here. All of this will be given to you. So I would suggest just watching and thinking about how you might begin to use some of these models, perhaps with your students, or if you work with teachers, various ways that you might find them helpful. So tonight, as Andres said, in addition to myself, we have Scott Steckety, who's my partner in the Dynamic Number Project, and we also have Elizabeth and Andres from Key Curriculum Press. So to start things off, I'd actually like to take a poll of all of you who are watching. And the question is very relevant to our webinar tonight. And the question is, do you use technology to teach decimals and fractions? Yes or no? So I'd like everybody just to take a second and respond so we can get a sense of people's use of technology.
Looks like we got 93% participation already.
Okay. And drum roll, the results are that 48% say yes, they do use technology, and 52% say no. So pretty evenly split. Okay. So, what is dynamic number? Well, for those of you who have used Sketchpad before, before, you may have heard the phrase dynamic geometry. And this is a phrase that began in the early 1990s when Sketchpad was first released. And when Sketchpad was released, one of the prototypic examples of using the software was this example here. I've drawn a triangle with 3 segments, and before I move anything, it just appears as one single triangle. But if I drag any of these vertices, I see that this triangle no longer stays just that one particular triangle. It can now become any triangle whatsoever. It can become a right triangle, obtuse, acute, you name it. And in this sense, we say that the object, this geometric figure, is dynamic. So when Scott and I began to think about the dynamic number project, we used that phrase dynamic number as a way of indicating that we want in some way the experience of exploring number to be as dynamic and interactive as it is with geometry. So what could that mean? Well, for those of you who have used Sketchpad a little bit, you may know about parameters. Here I have 2 parameters. And parameters are just essentially numbers, and they're numbers that have names, in this case A and B. And I can change the value of either one of them. I can make A equal to 3, I can make A equal to, say, 5, and I'm changing its value. I can also select A, and using the plus key on my keyboard, I can increment its value, or use the minus key so that the value becomes smaller. I can do the same with B, and when I use the plus key with B, here I've set it so the value of B is incremented in tenths. So this began to give us some sense of what it means to think about dynamic number. If numbers can change, just like the triangle here can change. But we wanted to push it farther than that. So we were thinking, what would it mean to explore the structure of decimals and fractions by being able to change their values? What would that look like? And in particular, what role does visualization and dynamism, the ability to change, in this case, numbers, play? There's not anything particularly visual going on here, except that, well, we can see that we're increasing the value of B, in this case, by tenths. And finally, what exactly are the pedagogical benefits and opportunities if you could make any fraction whatsoever that you wanted? In school mathematics, typically textbooks will show from fractions like 1/2 or 1/3 or 2/5, and we very rarely ask students to do anything more than just write down those fractions. There's very little opportunity for students, for instance, to be able to draw a fraction like 3/11, and that's pretty understandable because it's really hard to draw a fraction like that. So tonight we're going to see what it means when any of those fractions whatsoever are just a click away. So I'm going to begin by looking at several decimal models, and then from there we'll move to fractions. So our very first model is one that for a long time we've been calling zooming decimals, and you'll see what it means when we say zooming. So here we have an interval from 0 to 10, and there's a point on that interval. And when we do this activity with students, we'll ask them to approximate the location of that point. And some will say, well, it's a little more than 6. Other students might say, it's between 6 and 7. And some students even might say, I think it's 6 2/10. Now we ask them to imagine what would happen if we took that interval from 6 to 7 and we were able to, using a magnifying glass, zoom in on it and get a really fine look at what was happening. And with Sketchpad, we can move beyond the imagination phase and we can actually zoom in and see what's happening. So by pressing zoom, that interval between 6 and 7 is expanded And now we see a second zoomed in number line that shows the same point at the same location, only now we see that this interval has some additional tick marks, and these tick marks represent tenths. So we have 6 1/10, 6 2/10, and so on, up through 6 9/10. So it sure looks like our point is at 6 2/10. And if I press show location, indeed it is. So I can reset this model and hide the second number line, and I can hide the location, and I can drag my point anywhere I'd like, and then ask students to approximate its location again. And as before, when we zoom out, we see that we can name this point to an exact tenth, in this case 4/10. So this was a nice model, and it occurred to us that not only was it useful to be using it in this fairly static form, and I say static because even though this second number line does zoom out, this point is staying at the same location. So what would it look like if we animated this point? Now when we animate this point over here is going to move too, because they're really the same point giving us the same location. So let's watch. I'm going to press animate point. And we see this point is moving at a nice slow clip. This point here seems to be moving faster, or at least farther. And if we look at this point, it's moving by tenths. And every time it's gone all the way across 10/10, our point here on the first number line goes from one whole number, for instance here 5, to the next whole number when our point on the second number line has traversed 10/10. So this model, by animating it, gives us a nice way to think about and actually visualize place value. Our models move on using the same idea of zooming. Here, for instance, we'll zoom once, and we see that our point is somewhere between 3 1/10 and 3 2/10. So this time we'll zoom again to see if we can get an even better approximation. And now we've hit it in hundredths to an exact value. We have 3 14 1/100ths, which for those of you who remember is in honor of this week, which was Pi Day earlier in the week. And as before, we can play this game over and over again simply by dragging this point and hiding the location. And we have another model here, which I won't bother zooming for you, but this time the model we zoom 3 times and we end with a location in thousandths. And finally, we build up to this model, and I'll zoom out here quickly on all 4 of them at the same time, which is what students like to do. And we see here, even after zooming 4 times, we still don't find a location of this point that sits exactly at a tick mark. So this process of zooming out and zooming out again and again and again, we get the idea that we could just keep on doing this and getting ever finer approximations for the location of our point along the 0, 10 number line. And in fact, when we show the location, we show it to many more digits than we even have here to give that sense of the process continuing. One other model that I'd like to show you tonight for decimals is called hit the target. Here we have something that we've been calling informally a scooting tick mark. It's a tick mark on the move. It goes where you want it to. So right now this tick mark is at 8/10. And our goal is to have the tick mark scoot all the way over here to this orange tick mark. And we're not told the location of that tick mark. That's what we need to do our best to approximate. So to begin our journey, I'm going to press go. And now I'm going to approximate the location of this tick mark. Well, if this is 8/10, then I'm thinking 9/10 is around here, and that distance from 9/10 to 1, well, that looks like about the distance from 0 to this orange tick mark here. So I'm thinking if this is 1/10, then this should be 1/10. So I'm going to say 1/10 is where I want the blue tick mark to go. So scoot along, blue tick mark. Let's see how you do. Looks like I got it. I can check. I will show the target value, and it is indeed 1/10. And I can play again by pressing new target. Each time I do, I get a target that lands exactly at 1/10. And students can play this with their partners. Now this version quickly of tenths becomes old pretty fast, and we move on to this new version where your approximations have to be even better. You need to get your tick mark so that it's exact to hundredths. So here's our scooting tick mark, and I'm going to press go so that it's ready to move when I give it a new value. And what should I estimate? How about 8/10? Let's try that. 8/10, ooh, oh, it passed. Okay, so 8/10, that was too much. Let's try backing up a little here. How about 7/10? Scoot along. Oh, not enough. So how about splitting the difference and trying 75/100ths? It's close. Maybe 77/100ths. Oh, too much. Let's back up. 76/100ths. We check. Yes, got it. So this process is actually kind of interesting. You'll notice first I tried to approximate my location of that tick mark by trying to hone in on the tenths first. I didn't go for hundredths. I figured it was somewhere between 7/10 and 8/10. And once I had that, then I went for the hundredths. And this is a strategy we see students use all the time with this. And I have to admit that when we first used this activity, both Scott and I wondered how much patience would students have to really get it to the hundredths? Would they just sort of stop when they got it nearby? And the fact is, they really do drill down with this until they get it exact. It looks kind of like a dry game in some ways. There's no real fancy animations or sounds, but students find this very engaging to play with. And the nice thing about this game, when you press new target, there are a lot of new targets you can get here, so you can play it over and over again. So I'm going to stop for a second, and Andres, check with you to see if we have any questions.
I'm just looking at it. There hasn't been that many questions, and I want to encourage those of you that are participating in the webinar to send us questions. We'd love to get questions, but I don't see anything right now. So why don't you carry on?
There, Andres, do you want to read the one suggestion? There was a good suggestion made.
You want to share that for me, please?
Yeah. Daniel, there's a comment that it would be nice if we could mark their last placement so that they could kind of reason up and down, but see you know, sort of have a shadow of where the last marker was.
That's a really good idea, and it's something that actually came up in the webinar last night. And what it got me to thinking as one way of perhaps handling that is not only to just have a mark where the last location of our tick mark was, but perhaps maybe to have two scooting tick marks and that you could alternate between them so that, for instance, if I used my first scooting tick mark to get to, say, 7/10, and if I left that there and used the second tick mark and I got to, say, 8/10, I could then see that my location I was aiming for was somewhere between those. So definitely a very good idea. Okay, so I'm going to move on and begin an exploration of fractions. And we're going to look at several different models of fractions tonight. And we're going to start with some area models. So our very first area model activity is to simply have students begin to make some fractions. They don't even really have to know that much about fractions. The goal is to just have students start building them. So here, we're asking students to make 5 fractions less than 1, and we give them the numbers that they can use as numerators and denominators of those fractions. So how do they make the fractions? Well, they come over here to our custom tools, and they click, and this particular document comes with 2 custom tools, a make fraction for circles and a make fraction for rectangles. I'm going to show you both, but we're going to work with circles for a while. So I'm going to choose make fraction circles. And let's see, what should I start with? Well, 1/2 is always a nice fraction to begin with, and that's less than 1. So to make the fraction, I'm going to first click on my numerator, which is 1. Then I'll click my denominator, 2. And now, just by moving my mouse, I see that I've latched onto this fraction, which represents 1/2 of a circle. So when I click, I place that fraction. So there's 1/2. I can now go with my tool still chosen and click, for instance, 1/6 and obtain a visual representation of 1/6. I might do 3/12. But these are fairly standard fractions, and students have seen these, and they're looking over here and they see this number 190, and they can't help themselves. They want to use those numbers because they're big and they're large and they just seem more enticing. So let's try 13/100ths. Can Sketchpad even do 13/100ths? Well, there we go. There is 13/100ths. I can't count it, all those little parts there, but guarantee you that is 13/100ths. And students love this, the fact that they can make any fraction whatsoever and see something like this over here. Absolutely, they go bonkers with this. It's another example of how something that seemingly very low-tech in terms of no real glitz, it really appeals to them because they don't get to make fractions like this. So here we have these 4 representations of different fractions, and notice we have this segment down here. If I drag either endpoint, the values of the fractions stay the same, but the size of the circles change. So if I want to make 10 fractions on the same page, I can use this tool to give myself space. Or if I'm only making a few, I can make them really large and allow myself to see them better. So our next challenge is to make 5 fractions greater than 1. So just to give an example of that, I'm going to go back here to my tool. And let's see, for less than 1, I found that the numerator was less than the denominator. So what if I now make a numerator that's greater than the denominator? So perhaps 7/4. Well, Sketchpad gives me a visual representation of that. I have here my one whole circle that's completely shaded, and then 3/4 of this circle is shaded, giving me 7/4. At this point, I still don't even have to know that much about improper fractions, but I can begin to create them here. I can make 15/4, and of course, students wanting again to try very large numbers may try something like 100 as the numerator and 1 as the denominator. And what do we get? Ooh, what do we have here? Well, I can see here 5 circles, and there's part of a 6th. How many circles do I have? If I just scroll over, we go, we go, we go, we go, we go. And, well, we have a lot of circles. Indeed, we have 100 circles. And if I want, I can change the size of those circles here by dragging. It'll be hard to get them all on the same page, and when I do, I can't even really see them all. But it's a very dramatic demonstration of what happens here when we're looking at fractions greater than 1. As dramatic as our previous page when we looked at something like 13/100ths with a fraction less than 1. So after students play with these models for a while, we want them to begin to be a little more systematic about noticing some patterns. So here we have just one fraction, 1/2, and its visual representation. And the directions say to use the plus key to keep increasing the denominator. And you'll remember at the beginning of this webinar I showed you when we had something called a parameter, which is just a number, that I could click on it and then use the plus key on my keyboard to increase it one by one. So I'm going to do that here. And click, and begin to look at this pattern of 1/5, 1/6, 1/7, and keep on increasing. And students very quickly want to see what happens when this number gets large. And we have a very nice dynamic visual representation of this fraction as it's changing, as the denominator is growing larger and larger. Now, a very common misconception that students have is that the larger the denominator of a fraction, the larger the fraction. This model here very quickly lays that misconception to rest. Here we see 1/75th. Students will typically say something like, I want to see 1/250th. So to do that, rather than continue to use the plus key, I'm going to double click my denominator, and in place of 75, I'll type a much larger value like 250. And again, the minute students see this as the whole class, you will get oohs and ahs over this, and you will start a very interesting discussion about what's going on here. So with Sketchpad, there's no reason to restrict yourself or your students just to those easy fractions. You can make anything you want practically.
So Daniel?
Yeah.
So we actually got quite a few questions here now. One of which you've I think already addressed, right? If the student chooses a numerator greater than the denominator.
Mm-hmm.
And then one comment is that this assumes that 1 is a single discrete object. However, one package, for example, could contain 3 items. Is there anything underway to alter this unit beyond one discrete object?
In this particular model?
Yeah, it's more of a, I think it's more of a general comment. Maybe we should save that one for the end when you have a chance to show some of the other things that you're going to show today.
I think it might be addressed by showing some of the models when we get specifically to looking at fractions greater than 1 using rectangles, perhaps.
Yeah, which is another question that's coming up. So, yeah, why don't we hold off and you can show some of the other models, and then we'll come back to these questions if you haven't answered them.
Okay. So I'm going to move along here, and yesterday I found actually that I needed to move a little more quickly to show everything. So I want to now...
Yeah, I'll just give you, I've got a couple questions too about custom tools and how that works. So maybe you want to address that at the end.
Is there a particular question about custom tools?
I think it's more, there's 2 of them. The question is, can you point the custom tools? Can you point it to anywhere?
This is Scott. Can I break in for
Scott.
1 second? I've answered the questions on custom tools,
Okay.
and I would recommend that we not address that right now unless there's a follow-up question that comes in later.
Okay, thank you, Scott.
I'll just say that these tools that we built here are fairly complicated to make, but the benefit of having made them is that they're really easy to use, so that for teachers using these in elementary schools, they need to know really nothing about custom tools other than how to select them and how to use the particular tool.
I think, Daniel, it'll be helpful for people to realize, too, that the custom tools are associated with the sketch.
Yes.
So when they receive the sketch, the custom tools are part of that sketch. You don't have to go find them or put them anywhere. They're associated with the sketch already.
Right. All of the custom tools you'll see tonight are associated with the sketches that you'll receive, and you can even take that custom tool and transfer it to a new sketch of your own if you wish. Okay, so I'd like to look at a few more patterns relating to fractions. Here, we again start with the fraction 1/2, and I'm going to use the plus key again to increase the numerator. And this time when I do, we see a different pattern. Now we see the denominator is always 1 more than the numerator, and our fraction, as our numerator grows, gets closer and closer to 1. We also have a pattern in this model where when I increase the numerator, here the denominator is twice the numerator plus 2. And as the numerator gets larger and larger, our fraction approaches 1/2. Now, in talking about fractions, I really can't leave out something that every teacher discusses, which is equivalent fractions. So here the challenge is to make as many fractions equal to 1/2 as you can. So, well, always good to start with 1/2 itself. And 2/4, 10/20. But of course, students want to use much larger numbers, so we can make 50/100, 40/80. And if we'd like to verify that these fractions are indeed equal, we can drag one onto the other and check. Here, when I increase the numerator, we see a whole collection of fractions, all that are equal to 1/2. And it's pretty interesting to think, how did we make this? How does this model respond to what's here? And in particular, when I'm increasing the numerator, how does the denominator know what value to be? And this gives us a chance to do a little bit of early algebra connection. And the goal is to make a fraction that stays equal to 1/2 as you increase the numerator. So our numerator is going to be n. And n behaves like all of our other parameters, in that when I use my plus key, the value increases. And I need to find a way to create the denominator. Well, I know that the denominator needs to be twice the numerator, and I want it to always be twice the numerator. I don't want to just calculate 2 times 22. I want to be able to calculate something that's going to work regardless of the value of n. So I'm going to use my handy-dandy Sketchpad calculator and compute 2 times n. Now, when I increase n, I see the value of 2n behaves accordingly. So I can come back here to my Make Fraction tool, click n, click 2n, and there's my fraction represented visually. And if I change the value of n, that behaves nicely. So, what about fractions that are larger than 1? We made some of those on the very beginning page of this sketch, but we didn't really look at how to build up to those. We just made one by clicking a numerator and denominator, and bingo, it just appeared. What if we'd like to discuss that in a slightly more constructive way? So here we have the fraction 1/5, and I'm going to increase its numerator from 1 to 2 to 3 to 4, and begin to ask students, what do you think is going to happen next? So we have 5/5, we have one entire circle shaded, we have one hole, and 6/5. Well, now we have 5/5 and another 1/5. 7, 8, 9, 10/5. So we have now 2 holes, and we could keep going. Now the Dynamic Number Project has several very well-known advisors on its advisory board who have spent much of their career looking at fractions. And I'll say that when they saw this model, some of them were less than happy. They said, well, okay, we have 7 parts shaded, but how do we know what the whole is? Here it's fifths, but I could look at this and say, well, there are 5 and 10, there are 10 parts, so maybe this is 7/10. Circles aren't so great. Maybe you shouldn't be using those. So we really liked circles, but we thought maybe there's another model we could use in addition to circles that would make this clearer. So we thought about a rectangle model, and that's where we come back over here to make fraction rectangles. And I'm going to make 1/5, and this time we have a rectangle. It's a purple rectangle divided into 5 rectangular strips. And again, I'm going to increase the numerator to 2, 3, 4, 5. And let's watch what happens when we go now to 6/5. Rather than create an entire separate rectangle to its right, just like what was happening with our circles, here we've just extended one extra strip beyond our unit rectangle. And when we keep going to 7/5, 8/5, 9/5, we continue adding more strips. And now what's going to happen when I get to 10/5? Well, now we do have an outline appear here of a second rectangle, but it's in a more muted color, in this case gray, so that keeps the primacy of our purple rectangle here. So we're hoping, and this would be something that would be very interesting to test, that this will perhaps alleviate some of the misconceptions that might arise with our circle model for fractions greater than 1. And it's something we'll have to see. So I'm going to pause there for you, Andres.
Wow, so yeah, people are, I'm getting a lot of positive feedback from different teachers there, and I think that you were impressive on the last activity to give the rationale for why this is perhaps a superior model to the circle model. One person's comment is it's important for students to see that 7/5 is equal to 5/5 plus 2/5, where the fraction is written below each image. Then the final mixed fraction is written 1 2/5. But and then there's a follow-up question on a tool folder, which I'm going to hold off on. But why don't we keep going since it's already 4:38, and I know you have some other models that you'd like to show us.
Yes, I am going to do a quick dive into a few other models, in particular models relating to number lines. And let's see, let's start here. In this challenge, the goal is to make fractions that add up to 9/10. And we have available to us as a numerator and denominator 1 and 10. This tool is similar to the one we used before. We can, again, click a numerator and denominator to create a fraction. So I'll create 1/10. Here, though, rather than create a circle or a rectangle as a visual representation, we create a segment of length 1/10. And I can take that segment and attach it to my number line. I can repeatedly use that tool, in this case, to create more 1/10s and attach them end to end. And I have to make quite a few of them here to add up to 9/10. So part 2 of this activity looks at that and says, well, is there a quicker way to reach 9/10? Well, one thing I might do is start again with 1/10. And then I might say, okay, so now I have 8/10, and 8 is an even number, and I have a 2 over here, so I can divide my 8 into 4 2s. So perhaps I'll lay a bunch of 2/10 end to end. So that's one approach. Another approach that I might take, and I'll just back up here, is I might say, oh, well, there's that friendly fraction that I know, 1/2. So I'm going to create a 1/2 first. Well, 1/2 is equal to 5/10. So that only leaves left now 4/10, and I can do that with 2/10. And then I can check my work. So this creates some pretty fun challenges just by changing the numbers that are available. So here, rather than the prior problem where I had 1, 2, and 10, now I have 1, 4, and 10, and I can think again about how to reach 9/10. And there are several ways of doing so. The most obvious way in some sense might be, again, the strategy of taking out a 1/10, which leaves 8/10, which can be broken down into 4/10 and 4/10. Another idea, relating again back to the previous model, is to notice that I have a 1/4 and break my 1/2 that I made in the prior model into 1/4 plus 1/4. Here we have a page where students can make their own problems by choosing what fraction they want to be their target and entering those numerator and denominator in place of the question marks. And they can also change the values of these numbers that are provided for them, or even remove one of them. It creates some pretty interesting games that they can challenge each other with. Now, there was a remark before about how important it was to think about a fraction like 7/5 as 5/5 plus 2/5. And I want to get back to that here because it's a nice connection. Here we move on to some challenges where the goals are to reach fractions that are larger than 1. So we might, again, in this case, start by doing something like making 1/10, and we might continue to make 1/10. We might have students make all the way up to 1, and then make an additional 1/10 to reach 11/10. However, if you think about 11/10 as 10/10 plus 1/10, that opens up a whole new strategy for you, because now I can click on 10, and then 10 again, and that gives me here my unit segment, 10/10. So there's 10/10, and there's 1/10. And we, in this set of activities, have this recurring, what should I say, a way of thinking about these where we have students think about what's the best way of doing this that saves the most time. So we can be slow and laborious and create 11/10 as 11/1/10, or we can take advantage of this fact that we know that for this improper fraction we can break it into 10/10 and 1/10 and just get over there right away to our target. Here we see another example, in this case 19/4. Some students might apply the lesson from the previous model and create 4/4 and another 4/4 and continue building up to 4 and then create a 1/4 to go the remaining distance. Or they might recognize that they can pull out more from 19/4 to start with. They could start with 16/4, which is equal to 4, and they can create that in just one application of this Make Fractions tool and get immediately to 4 and then go the remaining 1/4. One other application that I'll quickly show of this same tool is for adding fractions. Here we have 1/10 plus 3/4, and I'm going to build that exactly as written on the very first number line. So 1/10 3/4. But on the number line below, I'd like to find a way that I can write these two fractions so I can actually add them together and get a numerical result. So pretty standard in this case, what I had in mind, 1/10 as 2/20 and 3/4 as 15/20. I can drag one right onto the other to see that they're identical. And now I can easily add them. So I'm going to now pause and see if there are any questions.
You know, it's hard to keep up with the questions and where you're at. There's a lot of comments. That people are saying that these models are powerful, that the number line's a nice alternative to the area models that you showed earlier. But again, unless Elizabeth can help me out here, I'm not seeing anything. There is the question of, is it possible to make 9/10 like 1 minus 1/10?
Good question.
And sorry, let me barge in here for a second. I did have a comment that your volume dropped, and I can't hear it on my end, but I know that when you're moving the sketch and talking at the same time, it warbles a little, so maybe just, I don't know, talk and then move. I'm hearing you okay, but we did have a comment that the volume had dropped.
Okay.
We also had a couple of questions earlier about if these things will work in Sketchpad 4.
These models, some of them indeed will. If we, I'm trying to think if there's any one in particular that wouldn't. There are a few here that would not, actually. But I suspect, certainly with the fraction circles, if those models we had here were saved as Sketchpad 4, those should work. We are encouraging people to upgrade to Sketchpad 5.
Which is a good point, and I would like to make that one as well. For those of you that are still using Sketchpad 4, you don't know what you're missing. It's really pretty amazing, the upgrades that have happened to Sketchpad 5, including a lot of support materials that come with the software. But anyway, so moving along.
It's worth mentioning that the sort of concluding zooming decimal sketch is one that's actually available already as part of Sketchpad Lesson Link for both Sketchpad 4 and Sketchpad 5. So that's one in particular that's available immediately for Sketchpad 4 users.
Okay, Daniel, are you going to do the 1 minus 1/10?
Yeah, I just want to show, people were asking, that question came up about adding and subtracting.
Yeah.
Here the goal is to find 1/9, and we have available 3, 4, and 9. So one way of doing that is to create the fraction 4/9, and I did that using the tool called add fraction, which is the tool we've all been using until now. And now, to reach 1/9 by subtracting 3/9, I'm going to switch over to the subtract fraction tool, create 3/9. But this time, my tool has me grabbing on to the segment on the right endpoint. So I'm going to match that right endpoint here to the right endpoint of 4/9 and create 4/9 minus 3/9, and that should give me 1/9 there, which it does. So this sketch you'll receive has several such challenges. I very quickly want to show the final model we have for fractions. Here, the goal is to find 1/16, and we have available a collection of tools. For this first challenge, I'm just going to use the halves tool. That's the way it's actually presented to students, with just halves available. By selecting halves, I can divide any segment I want in half. So for instance, I can click 0, and as I drag, I get this segment, which stretches, but always shows its midpoint. And now I'm going to click on 1, and I've just divided the segment from 0 to 1 in half. I can now label those parts. Since I'm looking for 1/16, I'm going to use 16ths as my denominator. So I'm going to label 1/2 as 8/16. For completeness, I'll label 1 as 16/16. And if I had 0 here, which I don't, I could actually label this as 0/16. And I can continue now by halving again to 4/16, 2/16, and 1/16. And very quickly, I'll just label 1/16 here for us. Now in this example, finding 7/12, we have a whole suite of these tools available to us, halves all the way through sevenths. So we might start, for instance, by creating sixths, and then switching over to our halves tool to create 12ths, to find 7/12. We could, of course, go about this in another way. We might, for instance, rather than use halves and sixths, we might choose fourths and then follow up with thirds. So again, just by providing this set of tools, it really gives us access to many, many questions we can ask students, because all of the fractions that in any way use these as part of their denominator are open to us to create. So there's our final activity for fractions, which is called dividing and subdividing. And to just return full circle, I want to talk briefly about the resources that are going to be available to you. First, you'll receive an email which will give you information for downloading a zip file, which will have all of the webinar materials that you saw tonight. The email will also contain information about a webinar recording, so you can go back and listen to the webinar again or pass it along to colleagues who might want to hear it. We also, and I'll just skip quickly to the last item here before returning here, Scott mentioned Sketchpad Lesson Link. This is a collection of over 500 Sketchpad activities for grades 3 through 12, which cover even more fraction and decimal activities than you've seen here tonight. It contains some of our earlier models from several years ago, and you can get a subscription to that and immediately get access to a wealth of Sketchpad materials. And finally, what I'm going to put a big plug in for is the dynamic number webpage. This is our site for our current project, where you can go and download all of the activities that we are creating. Not just the sketches tonight, but full activities with teacher notes, worksheets, everything. And we are updating this page on a monthly basis, so you will find new activities there all the time. There are short movies you can watch on this page which show you how to use the sketches. And I would encourage people to try the activities and to send us feedback. The best way for us to make these activities even better is to get your feedback. So with that, I am going to now pause and give it back to Andres one last time.
So, so interesting comments here about, there's even, you hear you're doing a presentation on elementary school, and I'm getting comments like, nice connection to calculus.
Oh.
The 1/2 plus 1/4 plus 1/8 and so on. There is a question about that somebody really likes the custom tools that come with this webinar, and they're asking if we're planning on doing a session for people that would be interested in making their own tools. And I'm going to, let me say one thing real quickly about these custom tools. I think it's great whenever, it's what I always did when I saw somebody else's sketch that they created. I was always, how did you make it? How did you make that? And you can look into it. Sketchpad 5 has some nice features, including the information tool, that makes it easier to sort of decipher how something was constructed by looking at the defining properties of every object. But But some of these tools are pretty complex, I found myself. And then other tools that you can create are more straightforward. So just want to warn people that it may be entirely possible that you say, oh, this is a great tool, and you start looking into it, and you might feel a little overwhelmed on how it was constructed, especially the ones that use iteration. But I don't want to discourage you from learning how to do those kind of things because it's pretty cool, and you're in luck because next week we're actually having a special webinar, and I'll let Scott tell you more about that because he's the presenter. Are you there, Scott? Okay, I heard him for a moment. He disappeared on me. But it is next week on, I believe it's Tuesday the 29th?
The week after next.
Oh, it's the week after next. Okay. So on Tuesday the 29th, and I don't remember the time off the top of my head.
Yes,
it's at 4 o'clock Eastern. I'm sorry. No, it's at 7 o'clock Eastern, 4 o'clock Pacific time.
So the same time slot as today's webinar, but on Tuesday in 2 weeks.
Yes, and I apologize for being so slow. I keep myself muted so that I don't contribute any noise to Daniel's presentation, and I couldn't find my control panel. I was in the middle of answering a question.
So do you know, can you tell us just briefly about what you're presenting on the 29th? I know it's more of an advanced workshop.
Yes, and it's actually a workshop it's a webinar that's going to address iteration in a variety of different settings, from sequences and thinking about sequences as an entree to thinking about arithmetic and geometric sequences as an entree to the ideas of function. We'll be doing some iterations to produce fractals. We'll be creating some very fascinating images, a Barnsley fern, for instance, through an iteration, which uses an iterated function system. So it's pretty wide-ranging in the mathematics that it explores.
Great. So that again is it's a special one. We have one of these a month, and but with some months there's a fifth week. Anyway, that's what's happening this month, and so we have a special presentation on the 27th. And then there's also our next regularly scheduled webinar is one that I'll be presenting in March. It's March 15th and 16th. I'm sorry, April, looking at the wrong date here. On April 19th and 20th, we'll be modeling periodic phenomena, and you can get information on that at our website. I might even show that to you, but Daniel, were you about to show something, or did you want to show something from the dynamic?
No, I was just quickly showing our website, which has all the curriculum materials on it.
Okay. All right. Well, I'm going to take the screen back if I can do this correctly, and let's see. And there you have just another. This is the periodic phenomena webinar that will be happening next month. All right. Well, I would like to thank all of you for joining us today, this afternoon or evening, as your case may be. And thank you, Daniel, for your presentation. Daniel and Scott, you guys are working on some fascinating new sketches. Truly a pleasure to see the interesting things you're developing, very powerful pedagogical tools for kids. And there seems to be a lot of enthusiasm from our participants today about these models that you've developed. Just noticed a question coming in about Macs versus PCs. Everything is dual platform. All of our stuff will work on both. And you will be receiving the sketches that Daniel presented. There'll be a follow-up email coming soon. That will also be, for those of you that are interested in signing up for credits, that you'll get information via email. But great job, Daniel. Thank you for your presentation, and thank you, all of you, for coming this evening. We'll continue answering questions for a couple more minutes, so if you have any more questions, go ahead and ask them now. But in about 2 minutes, 2-3 minutes, I'm going to go ahead and close the webinar. And I'm going to stop talking because it is now 5 o'clock West Coast time. Thanks again. Good night.
Night, everyone.